Hello students, we will solve one more numerical from block diagram. Okay, so the same question to find transfer function from block diagram. Okay, so we have solved one numerical. Now we will see second numerical to get the transfer function. Okay, so we will see the rules. First we need to find the number of nodes. Okay, so look at this. Here summing point is there, so I will consider node number 1. Here again summing point, so node number 2. Okay, then see here one more summing point, node number 3. Okay, now see, I told you if takeoff point, this is takeoff point, if takeoff point is before summing point, so we need to consider these two as a separate node that we have already taken in the previous numerical. Okay, now here you can see that this summing point and takeoff point are adjacent to each other and there is no block in between these two. Okay, so when the takeoff point is after summing point, then in that case we are considering these two as the same node. Okay, now see next node number 4. Okay, so now here summing point is there, node number 5, again the same thing. Here takeoff point is after summing point. Look at this, takeoff point is after summing point. Okay, so we will consider these two as a same node, node number 5. Okay, so you can compare the previous numerical and this numerical. In previous numerical the takeoff point is before summing point, so we have considered these two as a separate node. Okay, so we will start. So see here, I will draw here 1 2 3 4 5. Okay, so 5 nodes are there, so I will label that node as node number 1 2 3 4 and 5. Then I will start drawing the SFG. See, from node number 1 to 2 there is nothing, so I will consider this as 1. From 2 to 3 G1 is there. Okay, then from 3 to 4, look at this, 3 to 4 G2 block is there. Okay, so I will consider 3 to 4 as G2 block. Then from 4 to 5 you can consider this as G3. Okay, then I will complete this. From 3 to 5 negative sign is there. Okay, 3 to 5 I will draw 3 to 5. Okay, and here gain is G4 but negative sign, so I will consider minus G4. Okay, then next I will complete this loop first. From node number 5 to 3, look at this, 5 to 3, H2 is there with negative sign, so 5 to 3. Okay, so this will be minus H2. Then 4 to 2 minus H1, 4 to 2 minus H1. I have just drawn here jumper so that there will not be any confusion that these two loops are touching each other. Okay, so I have shown this H1. Then next from here node number 5 to 1. Okay, see no gain is there but with negative sign, so I will consider 5 to 1. Okay, so 5 to 1 with unity gain. Okay, just check whether we have drawn completely or anything left. Okay, I have shown here H1, H2. Okay, H3 is not there, then I have shown G1, G2, G3, G4 I have shown. Okay, and this is R and this is C. Okay, so this is signal flow graph. Now we know how to find transfer function from signal flow graph. Again I will write the formula, that is Mason's gain formula. So transfer function is C of S upon R of S. Laplace transfer of output to Laplace transfer of input is summation of Pi upon delta I upon delta. Okay, so I will calculate step number 1. So step number 1 is step number 1 is forward path gain. Forward path gain. Okay, so we need to calculate number of forward path first. Look at this, starting from input to output, this is first forward path, so I will write P1 is equal to, write down the forward path gain G1, G2, G3. So this is first forward path. Now see the direction. Here second forward path is there, G4, it is going towards output, so I need to consider second forward path. P2 is equal to, here 1 into G1, so I will write G1, and here G4 is there, so minus G4, so I will write minus G1, G4 is second forward path. Okay, so these two forward paths are there. Then next, step number 2, I need to calculate number of individual loops. Okay, so step number 2 is individual loops. So I will write L1 is equal to, okay, look at this. First of all, I will consider this bigger loop. Look at this, 1, 2, then 5 and back to this. Okay, so this is bigger loop. So I will write L1 as G1, G2, G3 and this plus 1, that is multiply by 1. Okay, so next, loop number 2. What is loop number 2? Now I will consider this smaller loop, G1, G2 and minus H1. Okay, so I will write G1, G2 and minus H1. Okay, so I have taken this loop. Now see, here one more loop is there, G2, G3 minus H2. So I will write L3 is equal to G2, G3 minus H2. So I will put minus here. Okay, so this is loop number 3. Now you can see this circle is there. Okay, so loop number 4 is there. So I will write loop number 4 is equal to, here you can see minus into minus, so it will be plus. So G4H2. This is loop 4. Okay, now you can see here one more loop is there. Okay, so you need to find correct number of loops. Look at this. Okay, this is outer loop, you can see here. Okay, so I will consider loop number 5 as L5 is equal to 1 into G1. Okay, then here minus G4 is there, so I will put minus here, minus G4 is there. Okay, then here 1, so I will multiply it with 1. So loop 5 is, again look at this, loop 5 is G1 minus G4 into 1. So it is coming back to input, so this is the bigger outer loop. So total number of loops are 5. Okay, you can see here there is no pair of two non-touching loops, because see, this is forward path and all loops whatever we have considered are touching to this both the forward paths. So no need to write step number 3 as two non-touching loops. Then again step number 4 as 3 non-touching loops are not there. Okay, now next we need to calculate this delta I. So what is delta I? Delta I is a term that is related with a forward path. Okay, so I will write delta 1 is equal to 1 minus, I will check 1 minus, okay, this is forward path. For delta 1 we need to consider first forward path, G1, G2, G3. So this is the first forward path. Just check whether there is any loop which is not touching to first forward path. No, all loops are touching. So I will write in bracket as 0. So delta 1 is 1. Okay, now delta 2. Delta 2 is equal to, look at this. This is the second forward path. This is second forward path. And again all loops are touching to second forward path. Okay, so what I will write, 1 minus in bracket it is 0. So 1. Okay, now I will put all these values in Mason's gain formula. So my transfer function is equal to Laplace transfer of output upon Laplace transfer of input. I will write here P1 delta 1 plus two forward paths are there. So P2 delta 2 upon delta. Okay, so put the values here. So P1 is what? P1 is G1, G2, G3. G1, G2, G3 into delta 1. Delta 1 is 1, so multiply it with 1. Then plus P2 is equal to minus G1, G4. So I will write minus G1, G4. Okay, multiply by delta 2, again it is 1. Then upon in bracket 1 plus, in first bracket we need to consider sum of all individual loops. Okay, sum of all individual loops. So I will put here G1, G2, G3 minus G1, G2, H1. Okay, then third loop is minus G2, G3, H2. Okay, then fourth loop is plus G4, H2. Okay, minus G1, G4 minus G1, G4. Okay, so see, this is your first bracket. This is your first bracket. Okay, in second bracket, as we know that there is no pair of two non-touching loops, otherwise what we will do, minus in bracket you can put here the values, but as there is no pair of two non-touching loops, so no need to write here this second bracket. Okay, So look at this. This is the transfer function. Okay. So from this block diagram, we have calculated the transfer function simply by substituting the individual loops, then forward path gain, and the delta 1 and delta 2. So I think you got the concept. Okay. So this is very simple method to get transfer function from block diagram. Okay. So if the method is not given, so I will tell you to use this signal flow graph, that is Mason's gain formula from block diagram. So thank you, students.